So let's practice with doing some integrals. And this might help with solving some problems. So we want to know a general formula for an integral that we might have to solve. And we're going to do the integral between two endpoints a and b of the function a times x to the n dx. So I can write a general formula that lets me solve this integral. And that general formula is going to be the integral of ax to the n is a times x to the n plus 1, all divided by n plus 1, between two endpoints a and b. And now I can plug in those endpoints. I start with the top one, and I subtract off whatever the bottom endpoint is. So I can plug in anywhere I see an x, I'll plug in a's and b's. So I have big A times b to the n plus 1, and I plug in that top limit first, all divided by n plus 1. Now I subtract off when I evaluate at the little a. So I do my function, my a times little a to the n plus 1, all divided by n plus 1. So this is a general formula that I can use to solve any of these kinds of integration problems. So let's say in a problem I'm given an equation for acceleration. I'm told that acceleration is equal to 3 times t squared. And I'm asked to find the velocity. Now the velocity is equal to the integral of the acceleration with respect to the variable t, with respect to time. So what I have to do is I have to integrate this acceleration equation to find what the velocity is, because the velocity is the integral of acceleration. So I can do velocity is equal to the integral of 3t squared dt. And when I do this integral, I'll get my answer. And I get my answer when I do integrations between two endpoints, maybe A and endpoint B. We can do this integral using our general formula. The integral of 3t squared dt is going to be equal to 3 times t cubed over 3 between the points A and B. All I've done there is I've used the general formula for finding the integral of a times x to the n. A times x to the n is a times x to the n plus 1 divided by n plus 1. So my number stays, my variable comes along, and then my exponent gets raised to the n plus 1th power, and then I divide by n plus 1. That is what I've done to integrate my 3t squared. My number stayed, my variable came along, I raised it to the n plus 1 power, and then divided by n plus 1. And now I need to evaluate at the endpoints whatever b is minus whatever a is. So my velocity here would be equal to 3 times b cubed all over 3 minus 3 times a cubed all over 3. And this would be my final answer for my velocity. Let's see one more example that kind of combines two different functions. So let's say I'm given a velocity, or an acceleration rather, that's equal to 3 times t cubed minus t to the 5th dt. D to the 5th. So this is my acceleration equation. I want to find the velocity. So to find the velocity, I know I need to do the integral of this acceleration. The integral of 3 times t cubed minus t to the 5th. And I need to do it with respect to time, with respect to dt. So here I have two different variables, two different equations. So I can actually separate these out. I can do the integral of 3t cubed dt minus the integral of t to the 5th dt. So I really have to apply that rule that we just talked about. I have to apply it twice, once for 3t cubed and once for t to the 5th. And the other thing I need to do is I need to know what limits I want to use. So typically in a physics problem, you would be given two different times. So maybe I want to know what the velocity is between 2 times, let's say maybe 2 and 4 seconds. So what is my velocity between 2 and 4 seconds? So those would be my limits of integration. I'd be going between 2 and 4. And I do that on both of these. So then my velocity is going to be equal to, well, I need to do this integral. My number stays, so my 3 comes straight down. My variable comes straight down. My t comes straight down. And then I take my exponent and I raise it up to the n plus 1 power. Here my exponent is 3. 3 plus 1 is 4. And then I would divide that by n plus 1, which was 4. We just saw that. And then I can do evaluate that between the points 2 and 4. Then I can do the second integral the same way. Here I have t to the 5th. My number comes straight down. And here I don't have a number explicitly out front. So the number I want to use is going to be equal to 1. So 1 comes right down. That's my number. My variable comes down, unaffected, t. And then my exponent, my 5, gets raised to the 5 plus 1 power, which is 6. And then I divide by 6. Divide by that n plus 1 using the general formula. And then I evaluate between 2 and 4. Now, all I have to do is plug in these numbers and evaluate. I have to plug and chug. So I can do v is equal to 3 times my final position. So I plug in 4 for my t, 4 to the 4th divided by 4. And then I subtract off 3 times the initial point, times the plugging in for that 2. So I plug in 2 for t, and I get 2 to the 4th divided by 4. And that is going to be the result of evaluating this first part. Then I need to subtract off the second part of my integral. So I plug in, again, the final position, which is that 4, plug that in for my t. I get 4 raised to the 6th power, all divided by 6, then minus plugging in my initial position, my initial t, my 2 raised to the 6th, all divided by 6. And then all of this you would plug and chug into your calculator and get a final equation, a final number for your v. So that's the basic structure that you use to find the integral of some function a x to the n. The integral of ax to the n dx is generally a times x to the n plus 1, all divided by n plus 1, evaluated at your endpoints, a and b.